Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend.
This video is for grade 11 students who are working on the year-end summative. It's question number 1.
A custodian is on the roof of a school throwing tennis balls down to the students on the field. The height of the tennis ball is given by this equation. So it's a quadratic equation, I can clearly see that, where h is the height of the ball above the ground in meters and t is time in seconds. So personally for me, whenever I get a quadratic equation, I always like to have some concept of what's going on before I even bother reading what I'm supposed to do with it. And this is a really quick process. I know that there's some guy on a roof and he's going to throw the ball in the air and it's going to come down. Now, again, I know that it's quadratic because t squared, that's the highest degree. And because the leading coefficient is negative, I know that it's going to look like this, and that's also just how things work. When we throw them in the air, they fall back down. So here, roughly, is what I'm thinking about for this equation. So question A says, from what height is the ball thrown? So there's not a lot of math I have to do here. And there's two ways to approach it. So if you don't already know the answer just by looking at the equation, let me explain. The ball is thrown from here. That's from the top of the roof. So if I can find the height when the ball gets thrown, I can tell you the height of the roof. Now, that is the moment that we start measuring using this equation. So that means that when time is 0, that's the starting height. So really what this is asking is find height when t equals 0. So you can take this equation and sub in 0 for t. And again, I'm hoping you already know what's happening here, but just in case, if you sub 0 in for that variable t, the first two terms will disappear and you'll be left with 9. So the ball was thrown from a height of 9 meters. And again, hopefully, you can look at this equation and see that the starting height must be 9. And it must be 9 because that is the vertical intercept, meaning that when t is 0, all that's left is 9. Okay, so that one was pretty easy. Now the next question asks us to find the maximum height. So let's get some more space here. Now maximum height, we know that in the world of quadratics, if someone asks for the maximum, that's a way of saying, tell me the vertex. So we need to find the vertex of this equation. So how do I find the vertex? Well, let's think about this. We're given a quadratic in standard form, so it looks like this. So we have options. One option is that we could factor and find the roots, and then use the roots to find the vertex. Now, I'm not too comfortable factoring. I'm very comfortable factoring. I don't like factoring when there's a bunch of decimals. It just seems like a silly thing to do. So another option is that we could complete the square. And completing the square is rearranging the equation in a special way so that I have it in vertex form. And then, of course, I can just tell you the vertex. So this one looks like it might be pretty okay to do the vertex form. So let's do it. Let's do the vertex form. Of course, let's just talk about the third option. You could have also found the roots by using the quadratic equation. If you use the quadratic equation to find the roots, then the roots can lead you to the vertex. But I'm going to try to use the completing the square method, because let's see what happens. So we need to complete the square. So the first step of completing the square is always to factor the coefficient a, or the leading coefficient, out of the first two terms. So when you factor a number to the front, you've basically just done division. So if I divide 9.8 by negative 4.9, I get exactly 2. And I get negative 2 because I have to be able to reverse the process. If I do negative 4.9 times negative 2, I'll go back to positive 9.8. Okay, so when you are factoring, what's left over inside the bracket is the result of division. But I didn't actually divide, I just sort of factored. Anyway, so that's the first step, and I have to add in the plus 9, even though it's not doing anything yet, it's still part of this equation. So the first step was to separate that coefficient. Now comes the completing the square section. So this is where I take this number, this negative 2 value, and I need to use that to complete the square. So what I need to do, and let me just remove some of this so I have some working space here. What I need to do is I need to find the one number in the universe so that if I have t squared minus 2t plus whatever, that this is a perfect square trinomial. And the definition of a perfect square trinomial is that it factors into a binomial squared instead of two separate and distinct binomials. So how do I find that magic number? Well, that's where we do this process. So I need to take this number, which is negative 2. I need half of that number, so that would give me negative 1. And then I need to square that result, and that gives me 1. So this is, I've written some bad math here, but that's okay. This tells me that the magic number is 1. And the reason why the magic number is 1, and I'll show this, and I'm comfortable erasing because I know you can always just rewind, because let's look, and let me just, again, cleanse the palette in a way. So now that I have my number of 1, let's review why that number 1 is my perfect square trinomial. If I wanted to factor this, it's a simple trinomial. So I know it's going to factor into t something, t something. So my two factors are going to look like this. And now I need to think of two numbers that multiply to give 1 and add to give negative 2. Well, the only things that multiply to 1 are the numbers 1 and 1 or negative 1 and negative 1. If I add those together, I get 2, so that doesn't work. If I add these together, I get negative 2, so those work. So if I factor this expression, I get this. And what you'll notice is that this perfectly matches this, which means it's really a perfect square trinomial, so it can be written as a binomial squared. So by finding this magic number of positive 1, I've turned these two terms into a trinomial that is a perfect square trinomial. And that's the whole goal of completing the square. So if I go back to this expression where I had this, I'm going to throw that plus 1 into that bracket because I really want to have a perfect square trinomial. But of course, I can't just walk up to an equation and add 1 because I've changed it. So how do I balance the fact that I've added 1? Simple. I'm going to subtract 1 because now I've really added 0. Yay! And all this is over there. So now here's my perfect square trinomial, but this minus 1, which I have to have, is kind of bugging me because I'd like to be able to factor this to a binomial. So I'm going to move that negative 1 out of the bracket. And so let's see what that looks like when it happens. So I have t squared minus 2t plus 1. So that's what I want in the bracket. That's my perfect square trinomial. And this minus 1, which I'm trying to get rid of, I have to remember, why is it in the bracket anyway? Well, it's in the bracket because it's being multiplied by negative 4.9. So if I want to take it out of the bracket, I have to show that it's actually negative 4.9 times negative 1, which is positive 4.9. So now I have my perfect square trinomial. So now's the point where I factor it into a beautiful squared binomial. And here I can just do 4.9 plus 9 is 13.9. So there's my equation. And let's highlight it for emphasis here. So there is the exact same equation I was given, but it's now in vertex form. And because it's in vertex form, I can tell you that the vertex is at 1, 13.9. There's the vertex. So the question was, what is the maximum height? And now I know that the maximum height is 13.9 meters above the ground. Okay, so we've done B. Now I have to determine when the ball hits the ground. Okay, so let me go to the next page. Determine when the ball hits the ground. So if you think about my little sketch, so this was the building, and the ball went like this, whee! And so what I want is I want to know this. When does the ball hit the ground? So in other words, I'm looking for an x-intercept or a root. And don't forget, there is another root, but it's imaginary. So there is another root over here, but it's imaginary, meaning that we can calculate it, but it doesn't have meaning in the context of the question. So how do I find the roots? Well, we can factor. I've already said I don't really want to factor it. We could use a quadratic equation. or we could use the equation that I developed up here. So I could use this equation in which I completed the square and solve for the root. So I think I'm going to do that. And one of the reasons why I'm doing that is not necessarily because it's the most easy or direct way, but because I know in other videos I use the quadratic equation over and over again, and so it's kind of nice once in a while to mix it up a little. So let's rewrite the equation. So the height was negative 4.9 bracket t minus 1 squared plus 13.9. So that's the equation we developed by completing the square. And I want to find the roots, which means the x-intercepts, which means I need to let the height equal 0. So I'm going to let the height equal 0 and then solve for t. So this is just now, at this point, equation solving. So here's t. The first thing I can get rid of is the positive 13.9. So I'm going to subtract 13.9 from both sides and get this expression. I don't know why I switched to green ink, but that's okay. Now I need to divide both sides by negative 4.9. Divide by negative 4.9. So I get a positive number. I get 2.84. So 2.84 is t minus 1 squared. And now I need to take the square root. And don't forget, this is where it's important to remember that when you take the square root, you get two different answers. You get a positive answer and a negative answer. So let me split this now into two separate answers. The square root of 2.84 is about 1.7. So I have 1.7 equals t minus 1, or negative 1.7 equals t minus 1. So if I add 1, I get 2.7. If I add 1, I get negative 0.7. So this is obviously inadmissible because it's the impossible root, or the imaginary root I talked about before, inadmissible, because time doesn't go backwards. So the ball hits the ground in 2.7 seconds. Okay, what else do we have to do? Sketch a graph labeling key points. Okay, so let me grab a piece of graph paper here. Don't need that one. This one. There we go. There's my grid. Okay. So what are my key points? Oops. Let me undo that. Oh, my pen is going crazy. So we know that, I'm just trying to move stuff out of my way here. Oh, forget it. I'm just ruining everything. All right. So we know that we have, that there's no point in discussing a negative axis or a positive axis. So I'll draw a line here, and I'll draw a line here. And yes, I use a tool to make sure that they're straight. That's not my handwriting, as you can tell. So this is going to be the height, and this one's going to be the time. So up here I have height, and that's in meters. And down here I have, pull this down a little, I have time, and that's in seconds. Now in terms of scale, I know that the ball hits the ground in 2.7 seconds, so there's no point in making a scale that goes 1, 2, 3 and wasting all this space. So I'll go 1 second, 2 seconds, and 3 seconds. I probably could have even made it a bigger scale, but that's okay. And in terms of height, we know the maximum height is 13.9. So 1, 2, 3, 4, 5, 6. Nope. So I'll have to go 2, 4, 6, 8, 10, 12, 14, 16. Okay, so there we go. And so now, what is the key information? We know that the ball height, we know that the ball starts at 9 meters, so that would be here. We know that after 1 second, it's at the maximum, which is 13.9. So I'll put a dot here. And we know that the ball hits the ground at 2.7 seconds, so right about here. And now, this is tough to do using technology. I'm going to connect those into a lovely, oh dear, oh, it's hideous, but oh well. There's my parabola. And my key points are at 0, 9, at 1, 13.9, and at 2.7, comma 0. All right, there's a rough sketch, very rough. And then finally, when will the ball be 1 meter from the ground? So it's telling me that if the height equals 1, find time. So if I go back to my sketch for a second, I'm looking for roughly this point in time. So I know that my answer should be pretty darn close to 2.7. That's why it's nice to have a sketch, because you can always tell if your answer makes sense. So what I need to do is take my equation and sub 1 in for the height, and then solve for t. So in this case, I'm going to use the quadratic equation to solve. So I'm going to make sure that it's equal to 0, because otherwise I can't use the quadratic equation. So there is the equation equal to 0. So t is equal to negative b plus or minus the square root of b squared minus 4 times a times c. And all of this is divided by 2a. And then, so this was b and b and a and c and a. Okay, so now it's just careful calculation. So t is negative 9.8. So if you type this in, take the square root. So, I'm not going to spend time here letting you wait for me to type stuff into my calculator. Obviously, if you're having issues with your calculator, come and get help. But that's what you get. So that's the whole root. So now I'm going to separate it into my two potential answers. So t is negative 9.8 plus 15.9 divided by negative 9.8, or t is negative 9.8 minus 15.9 divided by negative 9.8. So here I get a value for t of negative 0.62. So that's on the sort of imaginary math only part of the parabola. So I'll put a little x through it. And over here, I get a value of 2.62. And that makes sense because remember, we know that the ball lands at 2.7. So at 2.62 seconds, it must have been pretty darn close to landing, like 1 meter off the ground. Ooh, very neat. Not really. So there's my answer, 2.62 seconds. Okay? Thanks for watching. I hope that helped, and see you on another video.